So let's take a look at solving this differential equation. Y prime equals y squared. So remember dy dx equals y squared first of all. You can separate the variables here. So you're going to have dy over, say, y squared is equal to dx. Now on the left side, because y is in the bottom, we cannot have the condition that y is equal to 0. So y does not equal to 0. Okay, so that's one observation. But then from there, we can just write it as, let's see, y to the negative second dy is equal to dx. Then we can just anti-differentiate both sides. In other words, this, right? Y to the negative second dy is equal to antiderivative dx this way. So go through the power rule. You're going to have y to the negative second plus 1 divided by negative 2 plus 1 is equal to x plus c, basically, the constant. So remember here, the integrand is 1. When you differentiate, you get x because the derivative of x is positive 1. So we will have here y to the negative first, and then negative 1 on the bottom, and then x plus c. Now, you can write this as negative 1 over y is equal to x plus c. Let's continue over here. Let's also add a condition. You know what? Let's make this y of 0 should be equal to 1. Then from here, just flip it, so it's going to become negative y, just flipping the left side. It would be equal to 1 over x plus c. Let's multiply the negative 1 to the right side, so y is equal to negative 1 over x plus c. Now let's say we want the specific condition y of 0 equals 1. So that means specifically that 1 is equal to 1 negative that is there. That's going to be negative 1 over 0 plus c, and then you solve this for c. So 1 is equal to negative 1 over c. So c is equal to negative 1, which means the final version is y is equal to negative 1 divided by x minus 1. Now notice something in this solution here. X equals positive 1 is a vertical asymptote. I'll just shorten it to VA this way. Vertical asymptote. So let's graph this. And we cannot just accept both pieces of the graph as the solution. So let's graph it. Negative 1 over x minus 1. And look at this graph. Let's label the point that we have. So we want the point y of 0 equals 1. So remember, that's a point. That's the point 0, comma 1, in other words. You see right here? Because x is 0, y is 1. So that puts us in this position right here. So the piece of the graph that goes to that point is this piece. The one on the other side of the vertical asymptote, so can't be reached, correct? That's the key phrase right here, this piece. That can't be reached. You can't cross the vertical asymptote. Which means our interval then of solution will look like follows. Will look as follows. You're going to begin here, but not include that because that's where the vertical asymptote is located. And then you will go forever this way towards negative infinity, see? Which means, in other words, this is a valid solution over negative infinity to positive 1. Right here. That's what this is referring to. And that's how you solve this kind of question. Leave a like if it's helpful. I'll see you in another video.